So, hello everybody. I would like to present now the topics and give you some ideas what is my field of research, and this is coincident with my field of teaching, where I teach. For those that do not know my person, for the colleagues from Vietnam, my name is Jackson Roehrig. I am professor in the field of water resource management, specialized in hydrology, and with a good background in geoprocessing, remote sensing. And I will not talk about a specific project, but maybe you keep in mind that I'm starting a new project in South Africa and in Brazil, a new cooperation, and I have also a cooperation we are preparing in Guatemala, where I have been 2 weeks ago, and also I have running thesis where we are looking for follow-up projects in Morocco, in the Philippines, in Argentina, in Vietnam, and in Brazil. Okay, so but the topics are related to all these countries. But keep in mind now, as a framework, the project in South Africa. This is a project on disaster risk reduction with different components, also including social components that I'm not going to supervise, I'm offering, but I have to talk to Professor Hamhaba, because then, as we did in the past, we would work together in these fields, and he as a first supervisor. So I will talk about just show my research fields that should be known, and then talk about some thesis proposed, some topics, and then some case studies, and about some former theses, so you have an idea the thesis I have done. So my field is flood management, hydrological modeling, water balancing, hydrology, hydroclimatological, meteorological stations, sensors, and then water availability, groundwater, sediment, and so on. This is the water. I'm a water specialist, no? And this is my field of work. Like Professor Sturm also, he will list probably something similar to that, but relate to wastewater treatment and urban drainage and to water supply. We are both civil engineers. So now, besides the fact that I'm civil engineer and working on that, our project in South Africa that I'm using here to illustrate the proposals is an interdisciplinary project. And this project has three main components. One component is social. It's related to the impacts of floods and droughts, and its own institutional arrangements, how is the information flow between institutions, and so on. I would like to offer that because we have other partners in Germany and in South Africa that will cover these topics, and that we would also like to join these topics, but under the supervision of Professor Hamhaba and with me, but I will stay in the background because I am related to the site and to the project, but I don't have the expertise. Then another topic that is a big one is geodata infrastructure. That means what is the infrastructure necessary to gather all the information and distribute this information, to issue warning and to compile it, to process, and so that this information comes in real time, because we are talking about fast process like a flood. It comes in real time, and then this information achieves the communities also in near real time, so they can react to that. So for you to know, one part is damage analysis, institutions, communities. One part is geodata infrastructure, that is GIS, and one part now is the water. That means precipitation and runoff, forecast, water levels, flood areas, and so on. And I picked some points related to this project. By the way, the partners in this project are the TU Dresden and the University of Stuttgart and our university until now, from the German part. And in South Africa, Pretoria. So one topic would be the analysis of sensors for disaster management. Sensors are not only technical sensors. It includes also communities and the role of the people, how it's called crowdsourcing, how people inform each other and inform institutions. That means for those that are not don't want to do a technical thing, how is the analysis of the sensors, including the users, who receives the information, who from the communities is distributing information, how reliable is information, all this stuff. That means it's a big block on sensoring. Sensoring means how to get this information. Please do not think that it's only a technical sensor for temperature or for rain. It's also the community as a sensor, or a person as a sensor. So this is because, you know, the number of mobile devices is growing, and this plays an important role in disaster management. The topic here is the mobile network and the communities and the mobile phones themselves and their role in the disaster management. Then the second topic is called GeoInt. That means intelligence. That means how to integrate satellite images, how to integrate ground data, interviews, or from crowdsource for mobile phones, all this information, and process and exploit them. This includes also non-technical means. That means, for example, information acquired by person on the field. If you have a flood event, or earthquake, or volcano, like in Guatemala, then the question is, which kind of sensor, that means camera, or what kind of equipment the people, the rescue people, have to have, or how can this equipment help, and how can the information from people be useful, how can it made available and be useful in disaster events. Okay, this is another. So we have one here, sensors. Here is how to gather all the information and organize it. And then this year is only about mobile phone, but this is as a more technical thing for maybe one or the other people from renewable energy that have a technical background, how to create. Yeah, the idea here is it's a little bit difficult to explain this short time, but you know, you have broadcast systems where an antenna will distribute information for all people. You have target information to the people. There are different schemes how to exploit and use mobile communication. Then another thing that we would like to do here, we did this in Africa. It was a success. It's been used, but we can improve it more and more. This is a pure, let me say, hand-on work, very practical. That means you go to the civil engineers, to the architects here, to the mechanical workshop here, and then we design here shelters, because these shelters during disaster, they must work during the disaster, they must be robust, and they must be protected against vandalism and thievery. This is a very nice work we did in a group. So if you want to do something related to product design, you have to think how to do. We did this here, for example, so that people cannot open this here and the screws. Everything is really product design. If it's funny for you, it's a nice thing. It's very useful, and many people are looking for that. GIZ and the local government, they are implementing now 600 stations of this. No, not now. They're planning 600. Now they are implementing some dozen stations in Mozambique, besides those that we did. So this is a work that is done here in Germany, in the labs here. Then we make a prototype. Then we test whether this is robust against vandalism. We break it if we can, and so on. And then it will be installed. Huh? That's the crocodile guy? This guy, he's carrying the crocodiles here. You know that. Huh? And we are installing here. And the crocodile is called Fatima, because she was an old friend of us. So, okay, then another, this is technical now. This, because you remember, this year has a social impact and a social part. Until here is a product development, let me say product, but here is more technical. How to get to to use all the people from water know this, how to use all satellite data, how to mix this satellite data with ground data and with radar if available, and how to get all this very fast. That's why it's called operational precipitation. You remember, maybe, you have heard maybe the flood in Wuppertal just 2 weeks ago. So it was a very high peak. And so I will put this later, we would like to make out of it a case study and see how could we improve the forecasting using different products. So here, for those that know that, we are using real-time precipitation data for operational purpose. Then another topic here, this is how to determine with satellite data flood areas. I think this illustrates well here. This is the digital elevation model, and this is a real case flooded area. It starts growing the river, grow and grow and grow, everything becomes a big sea. Okay, so in the field of here, and this here is what we would like to do, maybe using Wuppertal for those that want to do in Germany. It's also possible to do the master thesis in Germany. I have good contacts with the Wupperverband, but with other agencies. We can use this case from 2 weeks ago as a flash flood case and then study what are the weaknesses, the bottlenecks in this whole event as one event. Well, we take more events, but this is an exemplary event. Or is there a standard operation procedure that means when it comes, do the people know exactly what they have to do to call, who do they call, how, what is the time in before, what is the time they had between the rainfall and the disaster, and all these things. We would like to study this here and then see the lead time, that means the time you have to react. This is not a hydrological study. This is a study on the procedure, how to act during a flash flood, or before and during. That means it's a post-event analysis of this flash flood. For example, a case study in Wuppertal, because the project in South Africa is also on flash flood. Then this year, maybe you know, this is how to use global climate models and satellite and real analysis products, how to use this here for certain regions. You have plenty of products where you can download this data, this from Germany and so on. And now, how can we use that? For example, I have now 5 master theses. Most of them are using that because the people are highly interested on that. In the Philippines, in Brazil, in Argentina, in Morocco also, they are using that. That means you have nowadays good, more or less good, seasonal forecasts that are for 9 months or 6 months. So we can use that to forecast droughts or to forecast what will be the harvest of some crops. And so there are many things here that we can do, but basically we take this product, downscale it to Philippines, to the islands in the Philippines, for example, and optimize it. That means we improve this because we have a ROF for the whole world, the precipitation in the next 6 months, every day or every month. Now we check that with the stations from the past. We take these products from the last 10 years because they are releasing this since 10 years, for example. We check every month from these last 10 years and see how does it perform in the last 10 years. And based on that, we correct it from the last 10 years. Now we have something corrected. When they release a new one now, then we use the same correction and we correct this, and then we can make a good seasonal forecast that can be used for many things. This is a very nice topic. It's a big field here that I'm just presenting as a talk. But did you understand that this downscale, this is called to regionalize this information. You regionalize to your area because this is global. This year I will give you the presentation. This is a little bit hardcore. There are different stochastic methods to disaggregate time series. That means we have daily temperature, daily precipitation, daily things, and we want to have sub-daily. Why? Because you have a middle, small watershed. When the rain falls and the water leaves, it's inside 1 day. You cannot have a daily. You have to see this precipitation, let's say 50 millimeters in 1 day, a lot. It's not, or let me say, 24 millimeters per day. It's not 1 millimeter per hour. Maybe the 24 fell in 10 minutes. So this is called how to disaggregate it. And this is really hard, but I enjoy this a lot. You can get my full support here for your headache and so on. Then, in general, I work with hydrological models. I don't have to say anything. Hydrological modeling is what we are doing in water system analysis, but also what we are not seeing with artificial neural network, multilinear regression. This is all modeling. Then there is another hand-on proposal that I have. You remember one was this shelter, to go to the architects, to the civil engineers, to the metal workshop, and design something and try something and so on. This is another one. We have a sensor here to see the bottom, a sonar for the bathymetry of the bottom of a lake. I want to construct, I did this, a prototype with a student here. A boat that you can drive, especially in such a day, very nice, on the lake. You drive this boat and then you measure the profile of the bottom of the lake. And this we can make operational, and then we can give it to the water agencies and so on, like in Ethiopia was important, or in Argentina also, Juan Salva, he's doing a master thesis on a sink, a lake that has no outlet. It's in equilibrium, the water that comes evaporates in equilibrium. But if more sediment comes, it changes everything. So they measure always, they drive this boat, but they don't have there. So if we have a boat that makes it automatic with GIS, we make the trace, and the boat goes, you make your barbecue and watch sometimes, and then it would be very nice. This is also a technical thing. So then, that's all about, do you have an idea what I do, more or less, no? Okay. Good. This is my objective. Now I have some case studies now, where I'm willing to work in this, this waterfall, Iguazu waterfall? It's a waterfall. It's a nice one. So, this is this river here, the waterfall is here. We would like to study here because here there are 5 dams in series. And there is a problem of dam operation optimization. They would like to improve the models here. And I would like to work here because I know the people, they were here for 2 weeks. We are trying to start projects there in cooperation with them. This is one example. The other one is what I told you, this is South Africa, and we will concentrate on the Limpopo River. And this is where you can do these sensors, or you can do this, for example, the community's arrangement for flood. Now we worked with community-based information warning system. All things, whether they are technical or more social, with Professor Hamaba, this is the region here in South Africa. But besides that, I told you I have 5 students now that are doing what I like. I have other students, but they do what I don't like. No, I'm supporting them. But these are the students I'm really, they do really what I like to do. Huh? So, and this is in Argentina, Brazil, in Morocco and Philippines, and in Vietnam, I forgot here, in Vietnam also. We would like to follow up this. That means all I told from modeling, from satellite, and everything that has to do with hydrology and water, we can do in all these countries here, in Germany also, and so on. Argentina is with an university. In Brazil is with this base I told you. This is with the Institute for Meteorology and Hydrology. Oops. Then Colombia is, we have a lot of, but this would be in Cali. Then Germany. Then Guatemala, where I have been. This is Guatemala is very indigenous. It has a large indigenous population, and this is a very rural project because it's with a university, and they have a lot of distributed campi, and they have a lot of things here. Please, if you want, talk to me about that because they do a lot of things that are not related only to my work, like, for example, ecosystem services, about natural resource a lot. If you want to do something in Guatemala with this strong university here, then talk to me. I will not supervise you. But I will talk to Udo Neren, or to Claudia, or no, to Professor Schluter, you suggest that, then you can do in Guatemala also this. Then Morocco is a GIZ project. This is a new cooperation with Professor Garcia University. This is with a colleague. I have been in Uganda in last years, and where you can make your thesis there. Obviously, I have a lot of contacts in other countries. And so let me show you some theses, just for you to see what I have done in the last years. Flood forecast in Koshi, Nepal. This is here sediment, hydropower in Koshi. This is Sheba in Tunisia. Where is Karim? Do you know this? You don't know him? Okay. This was water demand management in Damascus. Then this was in the Dead Sea, sanitation, groundwater in Bangladesh, flood in Vietnam. This year, land use cover impact in Ethiopia, flood water harvesting, it's in Sudan, groundwater resource in Bangladesh, this TESTA in Bangladesh, Sierra Leone, but this I don't do anymore. Sierra Leone, yes, but not sanitation. Then this Limpopo, Nepal, Mozambique. You see, community-based early warning system. This I did with Professor Hamaba, because all these communities arrangements and their roles and so on, this we do together. Depending on the emphasis on the project, if it's more on, because it's community-based early warning system, if it's more related to the early warning, that means who tells what and how long does it take and so on, it's more a hydrological thing. But if it's the role of each one in the committee, sorry, not in, each community has a committee with 18 persons with different roles, then the Professor Hamaba is the man. So then we have here hydrological modeling, then Mozambique, then mobile here. This is the influence of climate change on drinking water supply. Then more in Nepal here. So what else here? South Africa. This was a inventory that we did for the GIZ. Oops. Then and so on. Water demand management in Santo Domingo, and so on. So you have an idea, no? This is what I do. You're welcome. If you want to do that, you're welcome. If you don't do another thing, then it depends on what you want to do. If it's very social, then it's Professor Hamaba. I'm unsocial. Okay. Thank you very much. Did I do it too fast? Too fast. It's nice. But we cannot leave, no? We cannot leave. So, please, questions. Any question? No question? Well, please, one question. No question. The TV is here. Yes. Oh, thank you. Shukran.
For the hydrological models that you showed us, you said that you're using HMS and SWOT.
For example.
Someone could come up with other software to get accepted?
Yes, any software. Mike 11 I did also. This TESTA barrage in Bangladesh was Mike 11. The TESTA barrage. Riverware, yes. But look, Riverware and WIP, okay? There are two examples. If you want to do that, it's okay. Now let's see what's the better arrangement. I can do that, but depends on what you do. Maybe I would suggest, if you want, and if Professor Ribe has time, then you could go with him, because it's more on allocation of different stakeholders and so on and so on. I did many of these theses, but maybe he's more interested. Maybe we talk to him, and if it's in a region where I'm more interested, like for example in Iguazu, you don't want to do that then, but if it's an example, then maybe we say, no, okay, then you can do that, in Iguazu I supervise. But if it's in Sudan, I know that Professor Ribe is working intensively in Sudan, then maybe you want to do with him. But I think we have no... I think that we have to discuss this with him now, but I think I'm more concentrate on quantitative hydrology. No? This is my field. HBV, SWOT, Mike Basing, no? With Mike 11, HEC HAS and HEC HMS. Then there are the German software here that you don't know, Talsim, Nazim, and so on. And what else? There is one that we will use in South Africa. This is called Top Kaki. K-A-K-Y. Okay. Yes, please.
Would you also supervise thesis that focuses on GIS and remote sensing, but more in a natural resources way, like land use change analysis or something like that?
Yeah, this is a.
In the-
Yes, no, better not. Better, because look, I think the land use change is not the objective of your thesis. Probably you want to track the land use change to get a conclusion that relates to, then I would say you do this with Udo, Claudia, Professor Schluter, and I help you. I did this. Who was the student that did something with elephants? You not you? That was, no. No, because there was elephants access to the water, and she was doing geoprocessing to do routing and calculate the route and the time they got, because due to the drought, they were walking more and more. So I helped her a lot, so give tips, but then I don't care about the elephants so much as about the water itself they are missing. Then I would say that Claudia or Udo are the people, huh? But I help you surely with GIS.
Okay, speaking of which, like this domain of the data processing and information analysis, do you believe that this is the future of the market?
Yes, let me say one thing. I'm not very.
Because they interpolate after this data of the Cambridge Analytica. It's not the algorithm that matter, but the data itself, how to collect and process it, especially for.
Yeah.
So do you think it is like?
I can say, but it's like a propaganda here. This is the future. Yeah. No, but it's true. Look, you cannot imagine that all these remote sensors and the aggregation of sensors and these products that are improving, it will not disappear. It will be always better. GPM is much better than TRMM. More satellite will be, and LiDAR are available. LiDAR is laser data are available. So it's obviously, if you have this skill if you are able to work with this data, you have a big instrument in your hand. Look, if you are doing water in the future, you must know GIS. Nowadays, it's impossible because you have to do everything in GIS. No? And the next step, the next requirement for the future is to know how to process data, because we have plenty data, so much data nowadays. And you are illiterate if you have all this data and cannot read the data. Then you are data illiterate, and then it's bad to get a job illiterate. So it does.
Okay, I'm illiterate.
No, but you have a job. No, in fact, this is your generation for data.
How can we contact you?
Yeah, you can contact me on Monday in the next lecture.